Bismillahirrahmanirrahim. Today we would be doing BCD input, converting BCD input to a Access 3 code and output. So first of all, you must be knowing that what is BCD. BCD is basically binary coded decimal. So in this would be having BCD. We would be giving our BCD input to the circuit, and our output that would be generated would be in an Access 3 output. So first of all, here we have the circuit. So let's start. In Access 3 code, basically what is Access 3 code? Access 3 code is that whatever the value comes in binary or decimal, you add a 3 to it. Like for instance, our value starts from 0 to 9. So in this we would do the 0 of the binary decimal would be 3. Also the B0 of the Access 3 would be 3. So we would be having to form a formula, and in this we would be telling that whatever the input we obtain, in the input it would convert it and stepped out into the needed and the desired output. First of all, we would be as you can all see, these components are having a certain character as naming them a certain values, like this is A, this is B, this is C, and this is D. And on the reverse side, this is X, this is Y, sorry, this is W, this is X, this is Y, and this is Z. W, X, Y, Z. Okay. So these are outputs, and these would be giving us results in the Access 3 code. So in this, first of all, we would be using different kind of components. First would be our logic state. Logic state is used in digital designing logistics, in which basically give accurate results of the logic given to the circuit. Then we would be using NOT gates and AND gates, OR gates, simple AND gates, simple OR gates, and the 3 input also AND gates. Then also we would be using, to deliver the output, we would be using logic probe. Okay, so one thing more, this is not technical mapping. We would be in the next part, we would be considering the technical mapping that is performed over here to just minimize the time limit and save the time. I've already performed this experiment. So we would, in this experiment, we would be doing just the stimulation, and I'm explaining it to all of you. First, when all of the circuits are 0, for this we have to make a truth table. If you do not have a truth table by any means, then we can also define a form it, solve it by handwritten or key mapping. That key mapping is really important. When we would be solving it through key mapping, we could also be consider having the equation that would be output of this equation would be that W is equals to A input plus BC input plus BD input. So this would be the equation for W. That would be the first one output. Then for the X1 we would be having B bar C plus B bar D plus B C bar D bar. As you can also see here that we have B input is coming well, absolutely fine, and C is having a NOT and D is having a NOT in it. And this would be given to the second input, that is X. Then for the third value of Y, it would be C D plus C bar D bar. And then last but not the least, for Z, we would be having D bar. Now considering all of these, we would be putting them in the values and forming it. So first of all, W, as we can solve it, so when would W be 1? If A is 0, B is 0, C is 0 and D is 0, then W cannot be equal to 1. The only case when W is equal to 1 is that either one of them must be equal to 1. Either it's A, either B, or either C. Because from through its equation we get that. Okay, but also for the solving it, we should be making this in mind that for B, C and D, both the characters should be 1. Okay, so for putting W is equals to 1, first we can either just open this 1 as 1, the first input as 1, and we would be having a 1. Then after that we can also do be converting this, so this also proves that when BC is input, then this also solves the equation, proves the equation, or BD is equals is 1. This explains the rightful equation. Now for the second component, that is x, to solve it we would be as we know, the equation for it would be from K mapping is B bar plus C, B bar C, B bar D plus B bar D plus B C bar D bar. To solve it, to know these equations, you must be solving it from K mapping, then you would be able to make it out through this. Okay, so to make x0, x1 would be either that D is 1 or C is 1, because we already have in it that we have a C or D in it, in its equation, which specifies it. Or either way we should be having B1. So let's check it out. First one, if B is 1, it proves that this equation is suitable. Then the next one is that if we have D is equals to 1. Okay. And here we also have proved it. Then if C is equals to 1, it's also proven that it will be forming. Then for the next step, we would be having for BCD plus C bar D bar. So in this equation, we could be saying that for y we must be having either all of the sims or 0, or either C and D both is equals to 1, or B is equals to 1. By this equation, we could be having that this or both are 0. This equation can only be proved for y is that either both CT are 0 or both CT are 1. If we convert this, both as 1, you can see here that it is proved. If both are off, then you can also see it is proved. Either we open this or this, just because it is both are 0 or both are 1, this simultaneously as in the equation, it is proved. For the last one, D is 1, Z1, it is D bar, means D should be 0 in case to open or close this last one logic of C. If we logic, then you can ask C that off. But as soon as we off it, we get a high input at this rate, and it converts to positive. This is due to a NOT gate present over here converted into D bar. And next, moving ahead to the technical mapping. Now in technical mapping we have been using NAND gates and NOR gates, and with the NOT gates, so this would be our circuit for here today. Okay, so for solving the equations we would be doing the same so first of all, from this we can see that if t is equals to 0, then our z is coming true. If both are positive, then our y is also being proved. Then if we have c is equals to b is equals to 1, we have our x also positive. This is also being proved. Like in this, and if our 1 is positive, then it would be resulting in the positive. This results confirms that our results are technically also proved, and excess 3 codes are generated. So hey, thank you everyone. Jazakallah.